So just now we look at the inductance, right? So for capacitance, you know that current leads voltage by 90 degree. Okay, so every time when you do a mathematical equation, which is V over I, and then I is actually 90 degree, so with the derivation that's going on and all that, you will know that your Lec3 is actually your negative J XC. My XC is actually 1 over omega C, which is 1 over 2 pi FC. Alright, know that this negative J actually comes from this side over here. So that's why in any particular point of time, if it's capacitance involved, purely capacitance, you do indicate your notation with a negative J. Alright, and XC is just simply 1 over 2 pi FC. Alright, if we just recall back of whatever that we have learned, alright, for your resistor, basically nothing. R will just be R, but your inductance, alright, is actually your omega L, right? Or we know it as 2 pi F, which is your omega L. Alright, 2 pi, you know, F is just the frequency and L would be the inductance. What unit is this? This is in Henry. Okay, similarly for my XC, alright, so for my XC, it's basically 1 over 2 pi F C. Alright, C is my capacitance, also in farad unit. Alright, but know that when we actually express it in terms of the impedance, right, the Z, let's say the question actually requires you to get the impedance of a circuit and all that, always remember that for the capacitance, you have it in terms of negative J. If you realize, if you look at the inductance just now, it's just J. So do know that these are the two important notations that you need to remember. Alright, so we have come up with some terms and some terminology and all that. I hope by now that you're clear about it. Apparent power. So we're going to look at apparent power. Apparent power is basically just denoted by S. Alright, S equals to VI. But for apparent power, okay, apparent power is when you actually take into consideration both resistive and your capacitance or and inductance. Alright, if you have taken into account all the power that goes through all the load here, this load can be a combination of your R, your C and L. Alright, so in this case it would be your R, your XC and your XL, because we're talking about the impedance here, right? So if we want to look at the power, we actually know it as apparent power. It takes into account all the components of your load here. That's what it means by the load over here, yeah? Combination of all these R, L and C. So it's known as S, equivalent to VI. VA here is the unit. Alright, you can see that by now it's actually pretty similar to whatever that we have seen even in the earlier formula, right? You can see that V is equals to IR, the P is equals to VI. So basically everything stays the same, only that when you have a combination of different components in a circuit, you actually have different term for it. Alright, so by now apparent power, please know that it actually takes into account all your R, L and C. Okay, so that's apparent power. So which means whatever load that you have in the circuit, that's what your apparent power is. If they ask you for true power or real power, alright, that means that they only want to know the power through your resistor. Okay, reactive power basically means that the power that's only individually, it could be the power that goes through your capacitor, that's reactive power, QC, or your inductor, reactive power QL. Alright, so just be very clear with the terminology and things like that. This is just how it looks like. Okay, they're just saying that basically what you will normally have is a plus sign, but if it's a capacitive circuit, alright, you will have a negative notation somehow. Alright, so P is what I have mentioned just now, the real power. Alright, where does this come from? The R of your circuit. That's where your real power, or sometimes they call it the true power. Alright, so just some term that you need to really remember. Reactive power basically comes from, could be your C or your L, or sometimes combination of both. Alright, anything to do with your C and L, Q, or what we know as reactive power. And S would be apparent power, where it takes into account all of these together. Alright, so that's basically it. So this is just just showing you a power triangle and things like that. What power triangle basically means is that you have it in terms of one triangle over here. So you see that your horizontal part will always be your P. Remember what your P is, your true power or your real power. Let me repeat again. This is the power that goes through your resistor. Alright, so only resistor. This is it. For Q, your reactive power. So it always lies here. It could be QL, it could be QC, it could be a combination of both. So it really depends on what's there in your circuit. If you take into account both your P and your Q, alright, this is your S, or your apparent power. Okay, denoted by VA in terms of the unit. Okay, so this actually stays true in the sense that sometimes in a circuit, if you have P or you have Q, then you can get another component. It's just like your Pythagoras theorem. You have two components, you can get the other component. Alright, so power triangle is important in that sense. Okay, so what else do we need to know about this? Just something for you to read through, I guess. Alright, so series and parallel circuit, I think this is kind of still pretty easy. Okay, just like what we have seen, just a brief summary. Your ZR will basically just be your R. Alright, impedance if it involves your R. Your impedance which involves your Z will basically be XL with a degree of 90 degree. Alright, just to indicate that what your voltage actually leads your current. Alright, and this one is the other way around. Okay, so that's just how it's being represented. Okay, rectangular form of how things can be written and all that. This is just sort of mathematical stuff. Alright, so series and parallel, I just want to touch a little bit on this as well, because we need to know the difference between series and parallel. If everything is connected one after another, this is what we know as it being in series form. Alright, if I want to get the total resistance, basically it just means that we sum all up together. Unit being ohms, denoted by this shape over here. Alright, if you want to get power that goes through each of these resistors, then it's purely simple. Alright, you just, as long as you know the I, you know the R, so it goes by your Ohm's law. Alright, this is just part of what you can use as a formula to get it. Alright, power, like I said again, this is also known as true power, or power dissipated by resistor in watt form. Alright, just to touch a little bit on Kirchhoff's law, if KVL, it literally means that the summation of voltage actually is equal to 0. Alright, that's one of the most important thing. It basically means that we can just draw a loop over here and then we indicate the plus and minus. Okay, so what happens here is that if it enters positive, there will be positive V1, positive V2, positive V3. This entering the negative, right? So negative E equals to 0. Alright, so that's how the representation goes over here. Okay, So that's just how Kirchhoff voltage law works.